Okay, this is section 7.4, which is going to look at using the normal curve to approximate binomial probability. So if you remember in 6.2, we did binomial probability, which was binom CDF, PDF, that kind of stuff. So let's review real quick. Binomial probability experiment has a set number of trials, and they're all independent. There's only 2 outcomes. So yes or no, this or that, one thing. And then P stays the same the whole time, which is your probability of success. Now we have this normal rule of thumb. So if NP times 1 minus P is greater than 10, we can use the normal curve to approximate those probabilities. So we're saying, hey, the population is normal. We can use the normal curve instead of binomial. So you start by checking that. If it is 10, then you can find the mean and standard deviation and use the normal curve. If it's less than 10, then you have to use binom PDF or CDF. If your data is continuous, so far we've only worked with discrete data. If the data is continuous, then you need to use these approximations with the 0.5 just to adjust that you can have those decimals is really what that's doing. It's helping it calculate all the in-betweens. So let's look at this. Example 1. According to the American Red Cross, 7% of people in the United States have blood type O negative. What is the probability that in a simple random sample of 500 people in the United States, fewer than 30 have a blood type O negative? So we could do binom CDF like we did in 6.2. It's a binomial experiment. But let's check and see if we can approximate that with the normal. So we're going to do N, P, 1 minus P, and test if it's greater than or equal to 10. So N is 500. That's the people we talked about. P is 7, the probability that they have O neg. And then 1 minus 0.07 would be our failure probability. So then we plug that in. 500 times 0.07 times 1 minus 0.07. And that equals 32.55, which is greater than or equal to 10, so we can use norm. So now we're trying to find fewer than 30. So we're looking for X is less than 30. So we would do CDF. And then our lower is negative 1E99, based on what we learned in 7.2. Our upper is the 30, because that's the highest we can be. And now we need the mean and the standard deviation. So our mean is NP, which would be 500 times 0.07. So if I did that, all right, come on, calculator. 500 times 0.07 is 35. So I'm going to put that in here for the mean. And then our standard deviation is the square root of NP1 minus P. So it'd be the square root of 500 times 0.07 times 1 minus 0.07, which is 5.7053. So that's what I would put for my standard deviation, 5.7053. So this is what I'm going to type in the calculator. So second vars, norm CDF, and then I'm going to type negative 1E99, comma 30, comma 35, comma 5.7053, and I get 0.1904. So the probability that they get less than 30 people with O neg blood is 19.04%. That's what that means. So let's look at another one. According to the Gallup, 65% of Americans are in favor of the death penalty. So that's our P. Erica selects a random sample of 1,000 adults in Will County, Illinois, and finds that 630 of them are in favor of the death penalty. So that's what she found. Those are those numbers over there in the pink. Assuming that 65% of Americans are in favor of the death penalty, what is the probability of obtaining a random sample with no more than 630? So we're saying less than or equal to 630. That's what we're trying to find. So let's test with the normal, or if we can do normal. NP 1 minus P greater than or equal to 10. So that's 1,000 times 0.65 times 1 minus 0.65, and we get minus 0.65. And we get 227.5, which is absolutely greater than 10. So we can use norm. So we're going to use norm CDF. We're less than again, so negative 1E99, 630. Now, we could do the math like we did up here in number 1. We could absolutely do these out and type those in. But another option is to just type it. So, So if our mean is NP, we can just type N times P for our mean. And then our standard deviation was square root of NP 1 minus P. So we can just type that. 1 square root of 1,000 times 0.65 times 1 minus 0.65. You can type them in just like that if you don't want to do the math out separate. And you'll get the same answer within pretty close approximations. So second vars, norm CDF, negative 1E99, 630. And then here I'm just going to type 1,000 and 0.65 in parentheses, then put a comma, square root, 1,000, 0.65, and then 1 minus 0.65, and I get, nope, that didn't work. All right, let's try this again. Square root, 1,000, 0.65, and 1 minus 0.65 there. See, up on this one, the second part wasn't under the square root, which is the problem. So if I do that again, I get 0.0924. So that is the probability that a random sample would have no more than 630. Now we want to say, does this contradict the findings? So their findings were the 65%. So it's like saying, is this result unusual? And 9% is bigger than 5%. So we would say, no, it's not unusual. It did not contradict because 9% is bigger than 5. If this had been 0.03, we would say, yeah, that contradicts that. So this is just saying, hey, we can use the normal curve if this is true. If it's not true, you still need to use the binomial, and it might be a little less exact at predicting. So that is 7.4. Let me know if you have any questions.